Good day, everyone. This is Federico Serafini from the BUGSENG development team, and welcome to another monthly presentation of the ECLAIR suite. Today, we start with a short introduction of the overall suite, and then we focus on the ECLAIR static analyzer. In particular, we will take a look at a selection of the new upcoming feature that will be released soon in ECLAIR 3.14. I'm really curious to get your feedback. You can write in the Q&A section for the entire webinar. We will reserve a few minutes at the end to go through all the questions. So please, if you need me to repeat or clarify anything, feel free to unmute your microphone and stop me anytime. All right, let's dive in. What are we talking about exactly? The ECLAIR suite is a set of products and services designed and delivered by BUGSENG to provide solutions for static analysis, tool qualification, library, and compiler qualification. Let's talk about the static analysis tool, what you can do with it, and how it is different from other tools. ECLAIR is on the market from something around 13, 14 years. Unlike older tools that have a hard time adapting, ECLAIR has been designed with modern technology in mind since the very beginning, and this makes it extremely flexible and precise. Here we have an overview of the key feature, but I won't waste time now reading the list. I will share this slide with you later. So let's see them directly one by one. With ECLAIR, you can continuously keep your code compliant to coding standards such as MISRA-C and MISRA-C++, and licensing-wise, depending on the coding standard you need to comply with, you can choose a package or combine them together to cover all your needs. The configuration of the tool is automatic, and please do not underestimate this aspect, because we have customers who spent more than 1 year configuring their old tools, and they could not dream of changing compiler because that would have meant starting all over again. Now instead, they have ECLAIR and their life is much more easy because ECLAIR intercepts all the invocation performed by the build procedure to the toolchain component and automatically configure itself. So when I say toolchain component, I mean compiler, linker, assembler, and the archiver. They are automatically intercepted, and later we will see an example of this. Of course, you can also play with configuration at a more advanced level, but this is typically not necessary, and you can start working within minutes after the installation of the tool. You can use ECLAIR how you like, from the graphical user interface, from the command line, within Visual Studio Code, or whatever IDE you prefer, and you can also use it in continuous integration with systems like Jenkins, GitHub, or GitLab. From the BUGSENG website, you can access eclair.com, where you can see what it looks like to use ECLAIR on an integration server. We keep there several open source projects like Trusted Firmware, Zen, Zephyr, and Linux Next, and they are all under continuous analysis for the compliance with MISRA and other coding standards. You can consult the report directly in your browser. You don't need to install ECLAIR on your PC, so if you're curious, just take a look at it. With ECLAIR, you can easily work with Docker containers and other virtual environments, which is very convenient under several aspects. For example, this is very useful to work in a frozen environment that is independent from system updates. Output-wise, ECLAIR has several kinds of reports, and depending on the information and level of detail that you need, you can choose the best one for the job and generate it whatever format you need for the occasion. For safety critical project, the project organization checker is very interesting. You can automatically verify architectural constraints to prove independence and freedom from interference of all your software components. The different functional safety standards refer to this concept using different names, but it is essentially the same thing. Interaction among components must be kept under strict control. In particular, failures in lower-level criticality components shall not cause failures in higher criticality components. I would say that it is not common to find a requirement management tool integrated in a static analysis tool. You already know that managing requirements in Word documents or Excel spreadsheet is not exactly the thing, and you also know that famous requirement management tool cost a lot. ECLAIR comes with an integrated requirement management tool without any extra cost. You can use it to keep track of your requirements and have bidirectional traceability information all the way down to the code and the test case. So ECLAIR will also point out the uncovered requirements and the code without a requirement associated. And the documentation that is produced by the tool, it is interactive, and in my opinion, it is also very beautiful. Now, I would like to say a few words regarding the qualification of ECLAIR. ECLAIR is qualifiable and it is certified by ToolSuite for the use in safety-critical sectors in compliance with the main functional safety standard. And when it comes to tool qualification, the ECLAIR suite offers three options: the functional safety pack, the qualification kits, and the qualification service. For some industries, the functional safety pack is enough. It is rather inexpensive and gets the job done. But for other sectors, like aerospace, certificates mean nothing. So qualification kits are the way to go. A strategic alternative also for aerospace is commissioning the qualification work to the BUGSENG safety team. We reproduce the environment and deliver all the required documents in 10 working days. Continuing to talk about qualification, the ECLAIR suite offers also two products that enable you to automate library and compiler qualification. For automating library qualification, we have Silica, and you can run Silica to know exactly what portion of a library is used in your project. For example, say that you're using the C standard library, which is huge, and you don't want to qualify it all, but just the part that you're actually using. And in this way, with Silica, you can concentrate your efforts on qualifying just what is relevant for your particular use case. For automating compiler qualification, we have CertRun, which is born in collaboration with our historical partner SolidSense, leader in the market of compilers and libraries qualifications. Compilers have hundreds of options, and the code that is generated depends on these options. So if you need to qualify the compiler, you need to know exactly which are the options that you're using. And instead of mapping and configuring all the use case manually, CertRun does it automatically for you, producing a configuration of supertest for each detected use case. And this speeds up the qualification work and avoids surprises due to manual error. So, okay, now that you have an idea of what we do at BUGSENG, we can start with the fun part. So let's see the tool in action. And the purpose of this practical demonstration is to show you how easy it is to use ECLAIR to analyze your project with ECLAIR. And to do this, we are going to download together a CRC implementation by Michael Barr. Michael Barr is a very known name in the embedded system environment. He, with this group, also developed a coding standard, which is called BAR-C, and it is supported by ECLAIR. However, now we are going to talk about CRC, which is a cyclic redundancy code, and is a type of checksum able to detect corruption of data transmitted between embedded systems. Here we can download the implementation by Michael Barr. Okay, perfect. We have it. Now I'm going to use the command line, and I'm using Ubuntu, but what you're going to see, it will be possible to do also in other operative systems, or the Unix-like most of the Unix-like operative system, but also in Windows and Mac OS. The first part of the demonstration, in the first part we will use the command line, and then later we will switch to the graphical user interface. So we downloaded the CRC code. What I want to do now, I'm going to unzip the file, which is here, and I'm going to create here a CRC directory. So let's go into this CRC directory. Maybe I should zoom a little bit. Okay, we have 3 files. I think it's a good idea to take a look at them. So let's see. Okay, we have a main file. Let me zoom in. A main file, which basically there are some prints because he's testing 2 different implementation of the CRC algorithm, CRC slow and CRC fast. Please note that this main file is also including some header files, for example, crc.h and some standard headers. So let's go to take a look at crc.h. We have some macro definition and the declaration of the user function. And in crc.c, we have the inclusion of the header file, some macro definition, and of course, the definition of some function, some auxiliary function. And we have CRC slow and CRC fast. Perfect. Now, let's try together to see if this code compiles, first of all. So I'm gonna use GCC. Let's compile main.c, crc.c, and link them together. Okay, so a.out, which is an executable, is generated. We can also try to run it, and it works. Perfect. So now, if we want to analyze this project using ECLAIR, for example, to see if there are violations of MISRA C 2023, I mean, it is very simple. I mean, the fastest way is to just recycle the build command and to use ECLAIR. ECLAIR is a driver which will be shipped together with the new version of ECLAIR 3.14. Now I'm going to add the -s option because I want to select the MISRA C service, which will enable all the checkers that are needed to see if this project is compliant or not. So now, what is going to happen when I will run this command is that this build command will be executed within an ECLAIR environment, and inside of the ECLAIR environment, all the invocation of the build components will be intercepted. And this is really useful because ECLAIR will configure itself and will catch automatically all the implementation defined aspect, for example. So let's run it. Okay, ECLAIR. Okay, there was a typo. Okay, first of all, we are testing ECLAIR. Okay, the analysis is finished, but let's look at the result later. First, let's try to understand what is happening. We are testing the clean and build command, which is this one. So if the build procedure does not raise an error, then we can proceed with the analysis, which ended successfully. And then we have the database generation, and then the results in the database are opened in the default browser. So here we have some overall information of the project. You can see a project name, which is given by default, the directory, a timestamp, and I mean, we could directly go to see the result, which are here, but before doing this, I want to really see together with you what is happening. For example, here in the overall information, we see the number of enabled services. We have 21 directives and 200 rules. This is all MISRA C 2023. If we click here, we can also see all of them with their headline. And something which is really interesting is the analysis frame. Let's look at the analysis frame, because we can really see what ECLAIR is doing during the analysis. Because look here, we have the compiler that is intercepted. This is the build procedures, and this is the first call to the compiler, because the compiler is called to generate this target, the first object file, and to do it, we use this translation, the translation unit composed by the main.c, the CRC header file, which is included, and also all the standard header, which are included recursively. And you can see here all the list of the header files. Note that for each file, we have a fingerprint, and this is for reproducibility, because functional safety standard prescribes that the analysis result shall be reproducible by third parties. So if you have the fingerprint of the files, you can be sure, you can really know what you are analyzing. So this is the second call to the compiler, because we want to compile also crc.c.c, which with these header files, to generate this second object file. And then this is the call to the linker, because we want to generate a.out, which is the executable, and we will do it by linking together the two object files. So here you can see step by step how all the toolchain components are intercepted. Okay, now we can take a look at the results. Here you can see we have some of the guidelines of MISRA C 2023, and we have these three columns. We have violation, caution, and information. A violation report is I mean, you will have a violation report when the tool is certain about a violation, is sure that there is a violation. While in some cases where the code is really convoluted, and also when the code is obscure, and also, I mean, a lot of MISRA C rules are undecidable. So in some cases, ECLAIR could be unsure if there is a violation or not. So in all these cases, ECLAIR, we raise a caution. So you can really distinguish, you as a developer, if you use ECLAIR, I mean, if you find a violation report, then okay, you know that there is something that you should fix. While for a caution, then you can inspect the caution and see if, and maybe there could be some false positive that you can also resolve, maybe just rewriting the code in a simple manner. And then we have information report, which are just information to the developer that we think that they can be useful, but we will see them later. So let's see an example of a violation. For example, let's see the rule 17.7. We can click and we see here the headline of the rules, which say that the value returned by a function having an unvoid return type shall be used. We have three violations. For each violation, we have the file and the line of code. Here we have the main, where there are three calls to the printf function, but the printf function returns the number of bytes that are written. And here we are just ignoring the result. And so we have a violation of the rule. Now, if we want to something really interesting, please look that ECLAIR is able to show you the code before the preprocessing and also after the preprocessing. If you look at the two last arguments of the printf, which are CRC name and check value, they are macros. And we can also see to which value, which is the expansion of this macro, as you can see in this example. And this is something really useful. So if you want to address this violation, we could also do it in our IDE. For example, now I'm using Visual Studio Code. I just enabled the plugin for the Visual Studio and then Ctrl-Shift-Click on the report. And as you can see here, I have ECLAIR is integrated with my IDE, and I can see the violation. Look, I can see all the preprocessed code. I can also see the violation. I can go to the next report. And so let's try to fix them. I mean, this is trivial because we can just add a cast to void to say, okay, I know that printf returns something, and now I am ignoring the return value, but and I know what I'm doing. So let's add a cast to void. This is the standard way of addressing this kind of violation. And I also would like to see other violation, for example, violation of rule 2.1, which say that, no, sorry, 2.1, okay. A project shall not contain unreachable code. Here we have just one violation for the reflect function. It's saying that the reflect function is never code. And why? Why is this happening? It's maybe looking also at the information report, we can understand what is happening. Because, for example, there is directive 4.4, which say that section of code should not be commented out. You can see that there are not violations. We just have information for this directive. Let's see them. And look what is saying, that there is some piece of code which are not compiled because they are under some inside some preprocessing directive. So this code is excluded and is exactly the code that you can see here. The code to the reflect function depends on the definition of the reflect data. And in our particular build with our option, reflect data is defined as its argument itself. So there is no call to reflect. So just looking at the information report, we are also able to understand what is happening, which is something really useful. Just a quick look to another violation, which is really interesting. Okay, I don't want to enter in the details of the essential type, which is not trivial. But look, here we have a violation which involves a macro. And here it's really useful to see the expansion of the macro, to really see where the violation is. And the violation, in fact, is in the definition of the top bit macro. So this is something really, really useful. Okay, so enough for this report. What I want to do now, what I want to do now is just to invoke the help of ECLAIR, which is a simple driver which allows you to run a command in an ECLAIR environment to perform some predefined analysis, and then the results are open in the browser. You can see some example of the command, some example of use of ECLAIR, and here you can see all the options. In particular, we can enable BUGSENG, which is the coding standard developed by Michael Barr. We can also enable the bug finder, some common software quality metrics, MISRA C 2023, MISRA C++ 2023. So ECLAIR is just the quickest way to use ECLAIR is something which I really suggest for someone which is approaching ECLAIR for the first time, because it's, as you can see, it's really fast. Now, let's see the capability of ECLAIR of auto-configuring itself. In fact, now we are going to analyze a piece of code with different compilers, and you will see that the violation will change. In fact, let's see, I'm gonna use ECLAIR it, and I'm gonna use this particular file first, and I will show it to you. What we are going here is the SEL extension means ECLAIR configuration language. Here we are configuring ECLAIR. We are disabling the BUGSENG coding standard, which will be enabled by default, and we are enable just 3 rules of MITRA-C. So to do this, we call ECLAIR it with -c option, and we provide the .scl file, and then we will call GCC with -c option into this input.def file. And let's see what happens. Okay, there is only one violation of rule 10.3. Let's take a look at them. Rule 10.3 says that the value of an expression shall not be assigned to an object with a narrower essential type. So maybe we should open this, and okay, let me restart. Enable. Okay, let's see what is happening. Okay. Here, the strlen function returns a size t, which is an unsigned long. So the expression on the right-hand side of the assignment is, as the report is telling us, is a 64-bit unsigned integer. But we are assigning this to an unsigned int which has only 32 bit. So this is a violation of the rule. And now I want to show you that, let me close this, and if I change the compiler, and for example, I use a compiler for a machine that has a 16-bit integer, then the violation will change. So I'm using MSP compiler, bin, let's see, MSP, okay, GCC. Now let's run. Okay, here we have the result, and we have 2 violations. And the rule that we are violation are different, because we have rule 7.2 and rule 10.6. Before, in the previous analysis, we had 10.3. So let's look at this violation. Okay, the first one. See, this constant is the value 39,321, which is greater than the maximum representable integer in an architecture with only 16 bits. And we are violating the rule 7.2, which says that the suffix u shall be applied to all integer constants that are represented in an unsigned type. So here, this constant is unsigned because it's not representable within a signed integer. And this is the reason why we have a violation. Here there is a missing u, which we haven't before, because before we were compiling to my personal PC, which has 32-bit integers. And we also have a new violation here. I want to show it to you. Okay. Another violation, this time the expression on the right-hand side of the assignment is 16-bit, okay, 60-bit exactly 60-bit unsigned integer, and we are assigning it into a 32-bit unsigned integer, and this is why we are violating the rule. Okay, perfect. I hope that I was able to convince you about the capability of ECLAIR of catching all the implementation behavior by default without any configuration, without writing complex and error-prone configuration file. Everything is automatic. So I think now we are ready to go to see the graphical user interface in action. And we are going to analyze again the CRC project, but using the graphical user interface. So here we have the ECLAIR GUI. Let me reset. Perfect. We have, as you can see here on the left, several steps. Let's keep the welcome page. Now we need to insert some project information, like the project name and where to save the configuration of the graphical user interface. Now I'm just going to save them into my CRC folder, and I'm going to call the file crc.hes. HES extensions mean ECLAIR configuration settings. So perfect. Let's save and go to the next step. Here we can choose which services we want to enable. For example, if we want to analyze the project with respect to MISRA, let's type MISRA, and here you can see all the MISRA versions which are available, starting from MISRA 98, MISRA 2004, 2023, 2012, with all revision and amendment, but we also have MISRA C++, 2008, and 2023. And you can enable services at the granularity that you prefer. For example, if you want to enable the package altogether, just type MC3. If you want to enable, for example, only the rules of Series 10, just type mc3.r10. And you can also enable single rules, but I mean, it's not something that now I want to do, so I will just enable MC3 altogether. And then I also would like to enable some metrics. I will enable the HIS metrics and also some other BUGSENG metrics. Let's see, exceeding metrics record. Perfect. Now I can also give a name to this service selection. I'm going to call it MISRA and HIS. This is useful because I can create another service selection. For example, I'm going to call it bar, and I will enable, for example, bar-C coding standard. So let's go to the next step. Here we can specify the task, so the clean task and the build task. Here we have some default values. Here we have, for example, make clean as a clean task and make -J4 for the build task. But this is just arbitrary. If you don't use Maze, if you use Ninja, it's perfectly fine. Just put your clean command here and your build command here. I mean, it's perfectly fine. And it's also, as you can see, multi-threading is also supported. So let's call this make clean, and let's call this make build. But I mean, now we don't want to use make. Let's just use clean manually. So let's call it clean manual. And so as before, we are going to use rm, and we will pass the -f argument to remove a dot out, and the manual build will be the direct call to the compiler, which is gcc, and we provide the two files, main.c, crc.c. Perfect, ready for the next step. Okay, configuration. Here, as you can see, we can put together the selection that we defined before. For example, we can choose which services to enable. Let's go for MISRA and HIS, and which clean task to invoke. For example, let's go for the manual one, and let's run the analysis. Okay, let's save. Okay, as you can see here, we have the output of the console. There is the clean phase where the clean command is called, and then we have the build phase with the build command. Okay, with this pop-up will notify us that the analysis is finished, and it finished without errors, which is good. And let's see, we can view the result exactly as before. Okay, perfect. Let's see. Oh, now you can see we have some other stuff here. We have some metric reports because we enable metrics. Let's sort by metrics, for example. These metrics are the HIS metrics, for example. They will tell us about the cyclomatic complexity of each function, which is something really useful to know. And we also have some exceeding metrics. For example, as you can see, okay, these are the exceeding metrics, sorry. Of course, they will generate a violation because you are exceeding some threshold that you set up before. Let's see, for example, this one. The depth of nesting of iteration and selection statement, we have 2 violations because we have 3 for this function, which is greater than the limit which was set to 2. Okay, good. For example, now I want to show you a violation and also how this report page is powerful. Let's say that okay, enough for the metric. We want to remove all the reports about metrics. Here we can create selection. I'm gonna call my selection MISRA only, and I'm going to show all the reports where here we can select different things. In this case, I want to say that my service should be MC3, which is MISRA. Okay. Show report only of MISRA. Perfect. So I have only the MISRA reports on top. All the other reports, as you can see, about metrics and exceeding metrics are now hidden. And perfect. What I want to show you now is let's look at this rule. Says that the standard library input-output function shall not be used. But I mean, they are only used, as you can see from the report, they are only used within the main function. And we can say that here the purpose of the main is just to test our CRC implementation. So we could say that we could deviate this violation. And I want to show you how we can deviate violation in ECLAIR. One of the methods to deviate violation in ECLAIR. Okay, let me close this one. I have prepared this deviation file, which I'm going to copy into CRC. Let's see. As you can see, it's a .htl file, so it's a file in an ECLAIR configuration file, which you can see now. Okay, what we are saying is first of all, there is a line of documentation. This will be the justification for our deviation, and we are saying that the use of stdio inside of the main.c file is deliberate and only for testing purposes. And this is the line of configuration. We are configuring the MC3.R 21.6 service, and we are saying to tag as deliberate all the reports which came from the main.c file for this particular rule. So what I want to do now, I'm going to provide this configuration file to ECLAIR. So this is something a little bit advanced, so I'm going to enable the advanced mode, and I will go to settings, and I want to provide this deviation.acl file. And I also want to generate some ODT documentation. So I'm going to set this to true, and I think we are good. Okay, so let's see if something changed. Okay, 21.6, as you can see, we still have 4 violation, but if we click on them, now you can see that all the reports are tagged as deliberate. Deliberate with the justification, with the documentation that we provide. This is the justification of this deviation. So, and also, if you want to also build a selection, which we will call, for example, tag, we can also filter reports if the tag is deliberate or not. So we can just say, hey, show me only the tagged reports, or the opposite. So now we are hiding the tagged reports. And since we generate also the ODT files, I want to show you, let's see, xdg minus open. Okay. Okay. Let's see, this is the last analysis we launched from the graphical user interface. You can see we have some folders containing ODT files. And this is the documentation that you want to provide to an assessor when you want to show that your project is compliant with respect to MISRA, for example, because here you will find all the information that we saw. So look, all the useful information, and something which is really interesting is look at that. For the violation of rule 21.6, here you can see that they are tagged, and this means, okay, I know I have some violation of this rule, but I look at them, they are not dangerous. What I'm doing is deliberate. So they are deviated, but they are justified. I mean, you are justifying. So this is something really useful, and as you can see, is automatically generated, and this is wonderful, I think. So I think that I'm done for the demonstration. I don't know if there are some questions.
Hi, Federico. Many thanks for your presentation. So I'm going to read the questions.
Okay.
So, first one. Previously, you added a deviation using an ECLAIR configuration file. Is there a way to insert deviation through comments in the code?
Yes, of course. There are, I would say, 2 different ways of deviating. We saw just one of them, which was using our ECLAIR configuration language, which is something really powerful. You can express something and without touching the source code. But of course, I mean, if you prefer, we also support special comments where you can put in the source code to deviate all the reports. You can also specify, for example, the number of lines that you want to cover. So yes, we also support in comment deviation. Yes.
You spoke about the tool in recognizing macros. Can you tell a bit more about this feature?
Okay. Yes, because I mean, as I already said, ECLAIR is able to show you the code before and after the preprocessing, which is really useful. And if this is something that you need, you can also enable a service which is gonna show you the expansion of every macro in the project. It's called b.macros. Now we can try it to see the expansion. Oh, let me close the result before cancel. Let me close this one. Okay. Okay, let's save the new configuration. And okay, let's see. The tailored reports. Let me remove the selection of before. And okay, b.macros. You can see that it will generate information reports, 13 in this case. And if we click, you can see that, of course, the code that previously was excluded from the compilation, the reason was that the reflect data expand to 0. So, I mean, all is working as expected. So you can see for all the macro, you can see the relative expansion, which is really useful. So if you need this, you can just enable the service and you will have this really useful, because you can check what is happening, because in big project you can also have a lot of different macros with different level, with different preprocessing directives. So this is just a small project, so I would say it's easy to find the definition of each macro. But when the project grows, it's not that easy. So a service like this could be really useful. Okay, so this is it for today. Bear in mind that the new release will be available soon, so some of the new features that you have seen today are not available with your current version, but if you have an active maintenance, you will receive the new version as soon as it is available, and as always, you log in into your Mantis account and you download it. So if you have more questions, please feel free to reach out, writing an email to info@bugseng.com. So good. Thank you all for joining. Have a nice rest of your day and talk to you soon.